First question I have for you is just trying to get an idea of who's attended Lunch and Learns or if there's any first timers online here in the group. If you could go ahead and vote for me here, you'll see that in the webinar window. Looks like we do have some first timers. I'll go ahead and show you folks what we're looking at. So we do have some first timers. So what the Lunch and Learns are intended to be is really a one-on-one session with the technical staff, myself, and there's other individuals at CAD Dimensions that host these. And we pick topics where, maybe there's areas that we haven't talked about in a long time. It's not covered in the training book. It's just areas that aren't dug into very often that may be useful to you, as well as topics that are common to everyone, like we did templates a few weeks ago. So the Lunch and Learns are not a sales presentation by any means. It's very technical, and again, we've dug into commands just to try to figure out what the developers are thinking as far as what's working and what's not working. So the hopes are, if you're attending these sessions, that you're getting something out of them, or at least getting an idea whether you may want to use a feature or you just want to steer away from a feature. This helps you go to that point. So one more question, and this is related to today's topic. Today's topic, we're probably going to be out of here a little bit early today because the topic's kind of short, but I looked at SolidWorks calling some of their features smart, and I just want to give an idea to the group, who's been using some of these tools, and maybe just review some of them just so we have an understanding of what they do, what they're used for, some of the gotchas, some of the things to look out for. I'm not saying I'm a fan of all three of these. They definitely have their fit, but let's discuss them today and see where those might lead us. So I'm going to go ahead and share that. So it looks like most of you are using SmartMates. The good thing is that's a very short topic, so we'll just discuss some of the ins and outs of SmartMates. And the reason I brought that one up is there actually is going to be some changes if you're participating in the beta program. You'll see one thing that actually makes a difference with SmartMates in 2014. But Smart Components and Smart Fasteners, looks like there's a very small adoption rate. The one my personal favorite is Smart Components, and you'll see why as we get going here today. So I'll go ahead and let's get started. So we're going to cover those three areas: Smart Components with Smart Features. We're going to talk about SmartMates, Smart Fasteners, and then we'll open it up for some Q&A and close off for today. So since there's only 7% of the group online that's using Smart Components, it's obviously an area that you could take advantage of. Now, Smart Components are best utilized if you have repetitive work. So here's 3 examples of repetitive work. What it allows you to do is associate components and features to a part that's intelligent. When you use that part inside the assembly, you can reuse all the intelligence associated to it. Instead of having to redraw sketches or re-add fasteners to fasten it to other things, what if they were all together, almost like a sub-assembly? And that's really what Smart Components is. I'm going to show you how to create them. I'm going to show you how far you can go with them. But realistically, they can be very simple, and they don't need to take very long to set up. We're going to create one right in front of you today. So examples, connector with mounting screws. Well, if I drag that connector in, why do I have to remate the screws, the bolts, recreate the holes in the component that I'm connecting it to? Maybe there's a cutout. I mean, all these things I have to do over and over and over again every time I use that connector. The same thing with retaining rings. Retaining rings always have the grooves, right, most of the time. So, why not group those together? Or if you use a certain motor that always have bolts and mounting holes, how can I utilize that? Now, there are limitations to what can be associated to a component, and all this comes directly out of the help file. But if I create a component, I can associate bosses, cuts for both extrudes and revolves, simple holes and hole wizard holes to the actual components themselves. So let's take a look at smart components, and then we'll come back to these two notes here. So what does it look like to use a smart component? Well, typically you either store a smart component in your design library or you just insert it as a normal component. In this case, when you think of something like a PEM for sheet metal, well, every time you add a PEM in the assembly, you need the associated hole. Well, what if you could just drag the PEM in, select from the PEM size, okay? Once you have that PEM placed and positioned, you can see right now there is no hole. Well, because it's a smart component, you select on the component in the tree, and you're going to see this tiny star on the component in the graphics area. Clicking on that star unlocks the intelligence, the smart features that are stored along with it. This tells me that there's a PEM hole that's stored with the fastener, and it's just looking for a face to place the hole on. Once you give it the information you need, you can see it now has put the hole for the PEM. Okay. Now the nice thing is, and you'll see, if I were to decide to drag a different PEM size in, let's see here, just dropped them right on the, well, the holes for the other PEM sizes, it just dropped right on there, are associated with the PEM size. So as you change configuration, it will also change the size. Now, how do we create this? So let's start out with something very basic. Now, there's two methodologies for creating a smart component. The one I like to use is something I call a trainer assembly. So I create a dummy assembly that has everything I need in it so that I can create a smart component from it. Now, in this case, I just have a piece of sheet metal, some metal to a certain thickness. And I'm going to just insert another component into this. So let me find my D connector here. And it does have mate references to it that pop it onto the surface, and that's fine. Otherwise, you're going to do what you normally do, which is position that component mated in position in the assembly. Okay, now obviously mine moves at this point. The next thing I need to do is to create the holes to fasten it to this plate or sheet metal or whatever it happens to be. Now, to do that, I'm going to go ahead and use our traditional methods of edit component. We're going to go ahead and open sketch, and then I'm going to use the existing edges of the connector and convert them, making sure I get the right shape for the cutout. I'm going to select my loop, make sure I got the right loop, and convert that. When I do my cut, we'll just do a through all cut, and I've created the cutout in the sheet metal part. Okay. Now we want to turn it into a smart component. Now, in order to do that, I want to store that cutout feature in the smart component. Well, it actually belongs to the sheet metal part now, right? If I expand this, you can see the cut extrude belongs to this, and it does not belong to the D connector that I placed in. Well, in order to do this, under the Tools menu, at the very bottom, you have an option to make smart component. So select your D connector, go to Tools, and this menu definitely is getting long, make smart component, and it brings up a menu to start your smart component creation. Now it asks you which component's going to be smart. and I'm going to skip over this for a moment, but we go down to features, and notice as soon as I click on features that it hides the components that I want to be smart. I can click this on, click this off to hide or show. But all I have to do is go right to the graphics area and say, you know what, I need that as well. Once I have that, say OK to the component, it's now a smart component. It can be reused. So I have it. I need to save it out. Let's just open the part. You can see that in the part itself, I now have a folder in the feature tree that is called Smart Feature. If I expand that folder, it shows any features and any references that are needed to use this as a smart component. There's a cut that's associated with this. Now, what you don't need from here on out to use this is the assembly it was created in. However, if you want to edit it, you do need the assembly. So let's just save this to my desktop for a moment. All right. And if I wanted to edit the feature in the D connector, you can see Edit and Defining Assembly on the right click. You can only do this if you have the assembly available. It will pop us back into the assembly, and I could go ahead and make changes. Notice in the assembly, and this is something that's unique to this feature. I've never seen SolidWorks do this before, but now it has this little edit definition box off to the right-hand side, and you can actually physically move it. If you hit edit definition, it brings you back to where we defined it. Realistically, you set it up and it's ready to go. You don't need to make any changes unless you add something in the future. So let's go ahead and open the part again. So we have everything we need. Now, how do we go ahead and make this into what we're looking at? Let's use my let's use this one here. So if we wanted to go ahead and insert the component now, my D connector, I can go ahead and drop that into the assembly. It smart mates in position. And now notice my little star that I have here for my smart components. If I select that, it's looking for the face that I'm going to cut through. And it's going to create the cutouts that I need for the connector. So it's real easy to create a smart component that includes the most basic features to fasten it to whatever you're connecting it to. So I'm thinking a lot of connectors and fittings and O-rings and snap rings and Zeus screws and all those different things that you might utilize this for. Once it's in the assembly, you will have a component listed, but it's going to be in a folder below the below a main folder called D connector, which is what you dropped in. You'll see that there's a smart component and then there's a feature associated with this. Now, if I go to the actual cover where the feature was placed in there, you'll notice that it actually does create a feature listed at the bottom of the tree for the other component, and it has an external reference tied to it. So everything kind of works in conjunction here. It's real nice to automate this. Now, what if we go a little bit farther with this? I'm going to go and open a trainer assembly that I have here for another one. So we have, let's see, this one here. So what if we took it a little bit further? Not only do we reuse a feature, but we also want other components to go with it. Those other components, when I pick different configurations, I need different configurations of those components. So this is what I call a trainer assembly, just like I did before. I created a dummy assembly with everything I need in it because I only want to do it one time. So in this case, we'll go ahead and do our Make Smart component. I picked the component that I want to make smart. And there's a couple other sections in here that can be utilized. The other one is to associate other components with this smart component. Now, what it doesn't do, like it does with features, is embed all of the sketch information directly into the part. What it does is understand all the mates, and it keeps a link to where these components are, and I'll show you how it can be utilized. So I can now tell the system, hey, you know what? These are my smart components. Make sure I get them all here. These are the ones I want included in when I drag and drop this in. We'll go ahead and grab the pulley. Maybe I can Windows select here. Oh, that didn't get out of them. All right, looks like I have everything. Now, what features do I want to include in this? Notice as soon as I go to features, it hides all the components that are listed, and I can say, you know what, I need these 2 sets of features, which is 2 cut extrudes in this case. Again, I can hide and show the components that I've selected. Okay. And we can go ahead and accept that one. Now, just as I did before, okay, we end up creating a smart component. I know it's smart. You can see the little star on here. If I go ahead and open that component, you'll notice that it only contains the one part, right? Doesn't have everything else. You can see if I expand that, I now have more folders listed underneath the smart feature in the tree. One is the 2 features, then all the components that are also attached or referenced, and then any references that are required. I can still use the edit and defining assembly, which brings me back to the original assembly, in which I can edit definition of how I set up the smart components. Now, one of the comments that I made is if we drag and drop like this base feature here, or the base component for the bearing, what if it comes in different sizes? And if it comes in different sizes, I want different size bolts or a different shaft size. Well, we can use some of the tools in Smart Components to help us do that. This is called a Configurator Table. Now, in this case, there's only one configuration of the bearing. But if you had multiples, they would be listed along the left-hand side. Now, what this allows you to do is for the end user, if they pick the default configuration, here's the configuration of each of those components it's going to use. And each of these are pull-down menus, so I can pick which configuration is going to be used when I utilize it. Okay. So once I have the smart component, let me just go back here, and I save it out to my desktop. I'm going to save that. Now I can use it. All right, so let's open something I can put in there. So insert components. I showed you through the drag and drop of the design library, but it can just as easily be dropped in using the drag and drop or insert component method. I go ahead and insert that in there. That's not what I want. And let's see, it's having trouble opening it. Yes, okay. All right, so it already has it. Insert components. Let's drop that in. Now here's the condition if it doesn't have any mate references, which I don't think it's a requirement. It does help you to have 1 or 2 mate references in here. Let's go ahead and mate the 2 together. Position it on there. Now to use the features in components, click on the little star, and now all the components associated with that are also listed, and you could choose to add all the components, to add none of the components, to turn some on and off, and then all I have to do is give it the face reference. And once I do that, okay, let me hide a few of these here so you can see this. Oh, my features didn't come through. Must not have got my feature directions cut correctly, but you can see that all the components come through along with it. And this is a great way, when you're adding fasteners or washers and other things that you're repetitively doing with components. This allows you to associate them along with the features to the same component. Now it can even go a little bit farther. Get rid of some of these here we don't need. All right, let's see. So one of the options in a smart component is to allow the component to resize itself based on a diameter. Now, this only works on cylindrical smart components. It only adjusts to fit cylindrical objects. So this won't work when you drag and drop using any other one. Only for cylindrical. I'll show you how this one's set up. But this is what it might look like. I have a bearing in here. You may have seen this example in the past. And as I drag this bearing out, it's at one size. And as I go over different areas of the shaft, you'll notice that it resizes. Okay, the bearing in the center. Now, this will allow me to, I guess that didn't resize properly, but it allows me to make a selection based upon a diameter change. Here's another example of ones that this one's not quite working correctly. I haven't looked at it, but you can see how the snap ring adjusts to the shaft diameter. This is part of being a smart component. In this case, I think I'm missing some diameters, so it's picking the right size here. But same thing. We go ahead and we want the components related to the bearing here, so we can go ahead and give it the references it needs. Here's the components it's looking for. Now, like I said in the beginning, just a little gotcha is it's got to be able to find these components. It's not embedding them in the smart component. It actually is like a reference, like an assembly reference. It needs to know where it's located. But in the end, I'm able to resize components, bring their features, bring some fasteners along with it using smart components. But let's take a quick look at how the resizing is set up in this case. So in order to edit this, I have to edit in the defining assembly, which opens up what I call the trainer files. And in the trainer files, when we use edit definition, there's a Autosize function at the bottom of the smart components. And when that's clicked on, it just asks for the face that's used for concentric mate, for mating it, what to compare it to. So it's looking at the diametric change of what you're dragging it onto, and then it has to decide which configuration to use based upon that diameter. Now it does that through this configurator table that we were pointing out earlier. If I expand this out a little bit and we go off to the right, this is why mine didn't work. You actually have the ability to specify a minimum and maximum diameter for each configuration. So in order to use an MPD16, maybe we want a certain minimum and a certain maximum diameter, and you can use those dimensions to pick which configuration you should use. But this only works for diameters. Okay, for cylindrical objects when you're dragging and dropping it in. So I think smart components is really neat. If you utilize them, I would say at the very least utilizing them for creating associated holes when you have connectors or components that are fastened to each other, and storing them within the library so you can just drag and drop and reuse the hole. Does it take a little bit of setup? Yeah. But unless you're going as far as this, where you're picking configurations and letting it auto-size, it doesn't take very long. You don't have to create a trainer assembly either. I do that because I like to have the trainer assembly, so if I want to edit it later and do some other things. However, you can take any assembly that you've already done. So if you've already put together a motor with the screws and the associated bolt pattern and the other component, go to that assembly, open it up, and create yourself a smart component from it, and then reuse it in a new assembly. So it allows us to kind of go in reverse. Let's add the components in the assembly and then add the features that it attaches to later. Okay, so that's smart components. Now, SmartMates is very simple, and I bring this one up, like I said, if you're 2014 beta, this is something that will change a little bit in how we utilize mates going forward. But when I watch individuals mate inside of SolidWorks, I rarely see them use SmartMates. Whether they just don't know it's there or only use it, sporadically, I'm not sure. But what SmartMates is the ability to create common mates very, very quickly using some shortcuts. Now, what you're seeing is directly out of the help. Some of the common mates and the symbols that you're going to see associated with it. Now, SmartMates can create one mate, two mates, and in some cases can create three mates at one time. Okay, so how do we utilize SmartMates? Let's get rid of all this here, and we'll take a look. All right. So there's two ways really to trigger, two methods to trigger SmartMates. One is while you're in the assembly and the components are also in the assembly, and another is from separate windows. Now, most of you are probably used to just selecting the mate tool and then picking the faces. However, every time you do that, you got to turn this on and off, and you got to go back and forth. Well, it's pretty obvious how this cover goes on here. Well, how can I trigger and use SmartMates to do this? Now, SmartMates is, like I said, a way of mating using common techniques like coincident, concentric. In order to trigger it in the graphics area, you hold down your Alt key. Now, if I hold down my Alt key and I select the cylindrical edge of this object, I can now drag it. Now, once I'm dragging it with my mouse, I can let go of the Alt key. The Alt key just triggers it. Now, what it's looking for now is something to mate that to. So as I drag it over cylindrical objects, you can see it will start to snap in place. Now, because I dragged an edge to another edge, I get what we call a pin and hole. Pin and hole allows me to create two mates at one time. As soon as I drop it, let go of my left mouse button, it will actually place the mate. If I wanted to flip the component, I can hit my Tab key while it's still showing me the preview. When I want the mate and let go of my left mouse button, it physically creates it. And now I have two mates in one shot here. Okay. So another example, I want this shaft to be concentric to this hole. Hold down Alt, drag it to the center of the hole. Now I have the concentric symbol, and it goes ahead and creates that. Now notice when I create one mate, I can even switch it to other mates. Okay, so if I wanted it tangent or parallel or any of that stuff, well, if I want this shaft, coincident with the end, I can drag the two faces to each other, holding down the Alt key. Once I let go, it brings up the mate dialog. Well, maybe I wanted this to be a distance. Well, this is going to be 2 millimeters. I can even do my flipping. So even though it says for common mates, you can still get to the other mate types using smart mates. Now I can continue to do this with all the components and add the rest of them in there, but I think you get the idea, and most of you are using this. But there's also another method that you may not know about for smart mating. If I go to the Move Component dialog, there's a Smart Mates icon in the Move Component dialog. Now when this is clicked on, this allows me not only the ability to just drag components with my left mouse, but now if I double-click a face, a point, a cylindrical object, it now changes to a mate icon. And if I select what I want to mate it to, it does the same thing. Okay, I can go ahead and change the mate type and move on. So double-click and click. Accept it, double-click and click, and it mates everything concentric. So this Smart Mates is kind of buried in the Move, because this is something that you'll see with the beta that could possibly be changing for those of you involved. But a different way of triggering this Smart Mates and the ability to go ahead and do that. Now, as I said, Smart Mates can also be triggered. I'm just going to pick one. Let's do here. From separate windows. So if you happen to be modeling and you have the component open and the assembly open, you can actually smart mate it in position from the separate window. So all you do is select the surface that you want to mate or reference and drag it into the new assembly, and you'll get the same referencing. As soon as I'm over something cylindrical that it understands, it will mate it cylindrically. So smart mates, I think it's useful. I think if you get used to adding a few mates that way, you can do it very, very fast. Smart? Yeah, it's smart. You will find that you'll have trouble with the final defining mate from time to time. So for instance, let's take this one. Let's see. Trying to give myself a position that's going to work here. So I need one more mate to lock this down. If I were to try to drag two surfaces to each other, that's probably not the right one there. Even in this case, that one actually worked. Sometimes when you're putting the third and final mate in, you tend to get them not to be able to solve. In this case, I was able to get that locked in without a problem. Okay, so that's smart mates. Now this feature, Smart Fasteners, has more functionality in it than people give it credit for, but also has some kind of gotchas and nuances that you really need to be prepared for if you're going to utilize this. Well, Smart Fasteners does require you to have Toolbox, so you're going to need the Professional or the Premium package. But with Toolbox, we can automatically add fasteners and stacks to our assemblies. In order to do this automatically, we need to understand what is not supported. It's not going to add fasteners in holes that are not, single holes that are not connecting more than one component. In other words, there isn't a mating hole in the component adjacent to it. It's not going to understand holes that are misaligned. For whatever reason, it's just not going to try to put a fastener in there. If you extrude a square with a circle in the center of it, what we call a multi-boundary extrude, it's not going to see that center as a place to put a fastener. It's not going to work on imported parts, imported bodies, or derived parts and bodies. But it does work on mirrored components. So let's just take a quick look at Smart Fasteners for a moment. It does require us to have Toolbox turned on, so in the add-ins, make sure we got Toolbox and Toolbox Browser. And if we look at a simple assembly here to start with, it has a bunch of holes. I mean, all these holes that could get fasteners. Now, because it isn't going to recognize single holes, it's not going to try to put a fastener in here because it's not connected to another plate. However, because this hole is lined up with this hole, if I were to insert smart fasteners through the entire assembly, it might try to put a bolt through both of them. So you often get somebody saying, oh, well, smart fasteners aren't smart. Well, they aren't because there's a lot of factors involved here. It sees these two holes as a line, so it doesn't know that you're not trying to bolt across both of them. So the best way to really insert smart fasteners is to not insert for the entire assembly. Now there's a command on the assembly toolbar, and it's also found under the insert menu once Toolbox is on. You may get a little message here depending on the size of your assembly just telling you if it has lightweight components that it will resolve them. I'm going to go ahead and turn that off. If I tell it to populate all, this is what I told you is, might be off. Now in this case, these must be misaligned, but it didn't even get all the holes that I would expect here. I got one here, I got all these holes, we got holes here. So, the populate all isn't your best bet, like I said. So if we use the method of individually selecting them, in this case I can select the hole here, which is an M8 clearance hole. It's going to look to any lined up features associated with that, and I can tell it to go ahead and add the fastener in there. Now what it's going to do is grab the default fastener. Now the default fastener, I'm going to show you where that's set. It also by default is set up to auto size to the hole diameter. That was a clearance hole for an M8, and you can see in this case that it grabbed an M6. Now why is that? Let me just exit out of here for a second. If you look at the mating component and we look at the feature associated with that, this is an M6 tapped hole. So it selected the M6 based upon the adjacent holes. So be diligent about looking at whether your holes are proper or not to be able to accommodate the fastener. But if you select the hole, we can go ahead and add the fastener. We do have the ability to change what we call the stack. The stack is adding washers and nuts to either side of the fastener. So for the top stack, I have my washer selections. If I want an external tooth lock washer, I can go ahead and make that selection, and it's going to keep the fastener length so that I have threads sticking out through the tapped holes. Now I can adjust the length if I like. I can also add a bottom stack. In the help file, there's also a reference page that shows what each of these are, just an image that you can print out. So if you're doing this, you can say, okay, hex jam nut, what are they looking like? So you at least have some reference here. So if I go ahead and add a hex jam nut, you can see that it goes ahead and adds that automatically. Now, what if I wanted to change the fastener? Now, in this case, I want to put a fastener in up here, so I can go ahead and insert smart fastener once again. I can go ahead and select the clearance holes and go ahead and add the fastener, and it puts in another socket cap screw. Well, I didn't want a socket cap screw. This button here, titled Edit Grouping, brings me back to what smart fasteners figured out when it looked at that hole. It saw that there's an M8 clearance hole in that component. All right, and it's using that hole to size the fastener. Well, most of the people that use smart fasteners don't understand the options that are in here. Well, first of all, I can actually flip the fastener in here. Now, in this case, it doesn't make sense, but you have, if you ever have them come in the wrong way, which is typically another reason why people don't use smart fasteners, is they will come in the wrong direction. Okay, because there is no front and back of a cut hole. You can go ahead and flip them. But you can also in here change the fastener type. So I can go up here and maybe I want a hex cap screw in here instead. I can go ahead and do that, and it will go ahead and change that type automatically for me. Okay. Now once the smart fasteners are added, there's a couple things. At the bottom of the feature tree, you'll have folders that are for the fasteners. If I expand that, all the components that were added by the smart fastener feature are all together. If I wanted to change any of these, I can right click and edit the smart fastener, which will take me right back into the selection tools and allow me to make any changes in there. You'll also notice that if I right click on the smart fastener, there's an option called mark up to date. Now if a hole happens to change in one of the components, the smart fasteners may go out of date. In other words, they haven't been updated to the hole size if they're auto-sizing. They'll have a little note on there, and you just say mark up to date, and they'll update themselves. Now, all of the defaults for smart fasteners come from Toolbox. If I go into Toolbox and configure or set it up, there's one of the tabs in the Toolbox Configure wizard is for configuring smart fasteners. There's not a lot in here, but it helps you to determine which washer sizes it should use by default. And also, if there's a fastener length change, you can specify the minimum thread engagement that you need to have for a fastener for tapped holes. If the component is changed, do you want the stack to change? And then most importantly, what is your default fastener? In this case, we're using socket cap screws, but if you don't use a lot of socket cap screws, maybe you're doing woodwork, you use wood screws. Well, set those up as your default fastener, and that way you don't have to make so many changes going forward. Now there's one other nuance that I kind of want to bring up here. Let's see here. I just tried to put together an example. I'm trying to bring out like the reasons why people don't use smart fasteners, because it looks like it acts erratically sometimes. If I go ahead and insert smart fasteners in this case, and let's say I used one of these faces, it's just a bunch of cuts. It's not a hole wizard hole. It's not any of that. You can see even it didn't even put fasteners in the right direction from the face that I selected. Well, now we know I can edit the grouping. I can go in here and flip the fastener without a problem. But notice in this case, all these holes were created with cuts. And it sees them all together. One is where the bolt side, the other one is the through holes fastened all the components together. One of the things you are able to do is reassign holes and break them from an existing series. For instance, in this case, I want a fastener going through this way, and I want a fastener going through in this way. Well, they're all lined up. The system has no clue that that's what you're trying to do, unless you were to take the feature and drag it out of here onto the group. It's called splitting the series. Now, splitting the series allows me to then have a second group, which is the fastener going through that other hole, and we can split it one more and bring this one and combine it. But now I have fasteners on both ends here. With that, I can go ahead and take my group. Now this message that you're getting here shows you there's interference in that the fastener length is shorter than the hole. So you can see it's shorter. I don't have enough engagement in the hole. But I can go ahead from here and flip the fasteners. I can go ahead and edit the fasteners out and give them more length. So let's see here. Once I edit fasteners, I can change the length and make them longer to accommodate the holes. And I can also edit this fastener as well, which is my first one, and shorten those up. So you do have some controls in here. Even though they may not seem smart to start with, you do have the option for reorganizing the series to give it a little more intelligence, because it just doesn't know direction. It doesn't know, depending on the feature. The best way to use smart fasteners is to use hole wizard holes and whole series in an assembly. If it's a series of just cut extrudes, you're going to get some different stuff, and you just need to know how to manipulate the smart fastener window a little bit to be able to accommodate that. So that's what I had for today. 3 smart tools. Maybe you think they're smart, maybe you don't. But hopefully you got something out of this. Maybe start using smart components and smart mates, and give some thought to smart fasteners. If you have any more questions, I can answer them in the questions section. For those of you who are online, if you have any topics, please email me at kevin@caddimensions.com, and we're looking for new topics, areas of the software that you want to learn a little more about, and we'll have future webinars on those. So I'll go ahead and stop talking, and if you have any questions, I don't see any in yet, I'll answer those. Have a good day.